Hello guys, and welcome back to my YouTube channel. In our previous video we discussed the heap sort algorithm and we write some code of our heap sort algorithm. So let's continue from our previous video. We have written our heap sort function. Now let's write our heap 5 function. Now we will initialize the largest element as root. Now we will check if L is less than n and the lth index of array is greater than the largest index of our array. Now we will call our swap function again. And after the swap function we will recursively call our heap5 function. So now let's write the code for our print array function. Now let's write our main drivers code, main function code. We will first create an array and give it a value of 12, 11, 13, 5, 6, 7 and the size of array call our heap sort function and we'll pass it the value of our array and our length. Print array function. Now let's try to run our program. So you can see our sorted array is 5, 6, 7, 11, 12, 13. So we have successfully sorted our unsorted array using the heap sort method. Now let's take a look at the time complexity of using heap sort method. The time complexity of heap sort method is O log n, and the space complexity is O of 1. So now let's also see some interview question relating heap sort. So first one is, what are the two phases of heap sort? The heap sort algorithm consists of two phases. The first phase, in the first phase the array is converted into a max heap, and in the second phase the highest element is removed, i.e. the one at the tree root or the parent root, and then the remaining element are used to create a new max heap. So our next question is, why heap sort is not stable? Heap sort algorithm is not a stable algorithm because this algorithm is not stable because operations that are performed in the heap can change the relative order of equivalent keys. Next question is, heap sort an example of divide and conquer algorithm. So heap sort is not at all a divide and conquer algorithm. It uses a heap data structure to efficiently sort its element and not a divide and conquer approach to sort the element. Our next question is, which sorting algorithm is better, heap sort or merge sort? The answer lies in comparison of their time complexities and space requirement. The merge sort is slightly faster than the heap sort, but on the other hand, merge sort take extra space. Depending on the requirement, one should choose which one to use. Next we have, why heap sort better than selection sort? So heap sort is similar to selection sort but with a better way to get the maximum element. It takes advantage of heap sort data structure and get maximum element in constant time. So now let's start our next sorting algorithm, which is counting sort algorithm. Counting sort is a sorting technique based on key between a specific range. It works by counting the number of objects having distinct keys value, a kind of hashing. Then do some arithmetic operation to calculate the position of each object in the output sequence. Some characteristics of counting sort. Counting sort make assumption about the data. For example, it assumes that value are going to be in the range of 0 to 10 or 10 to 99. Some other assumption counting sort makes is input data will be all real numbers. Like other algorithms, this sorting algorithm is not comparison based algorithm. It hashes the value in a temporary count array and uses them for sorting. It uses a temporary array, making it non-in-place algorithm. Now we will take a look at an example of counting sort algorithm. For simplicity, consider the data in the range of 0 to 9. So we have our input data 1, 4, 1, 2, 7, 5, 2. Take a count array to store the count of each unique object. Follow the below illustration for better understanding of counting sort algorithm. The illustration is, for simplicity, we have this data from 0 to 9 range and its indexes are all 0. Count each element in the given array and place the count at the appropriate index. Now store the count of each unique element in the count array. If an element repeats itself, simply increase the count. So for example, this one appears 2 times, so we increase its count by 1 and now its count is 2. Here the count of each unique element is the count array as shown in below. So we have 0 0, so the indexes are 0 1 0 to 9, and we have our count of 0 2 2 0 1 1 0 1 0 0. For simplicity, consider this data range and their indexes are 0 1 2 3 4 5 6 7 8 9, and their count array is given below: 0 2 2 0 1 1 0 1 0 0. Modify the count array by adding the previous counts. So modify the count array such that each element at each index store the sum of previous count. So for example, in case of this indexes, the modified count array indicates the position of each object in the output sequence. Find the index of each element of the original array in the count array. This gives the commutative count like this, and then we have this 4 plus 0. So rotate the array clockwise for 1 time, then we will have our count of 0 0 2 4 4 5 6 6 7 7. Output each object from the input sequence followed by increasing its count by 1. Processes that input data 1 4 4 1 2 7 5 2. The position of 1 is now 0. Put data 1 at index 0. Increase a count by 1 to place next data 1 at an index 1 greater than this index. So we will keep doing this until our array is sorted. So now we will try to implement this code in C++. So let me clear all of our previous code. Let me include 2 more libraries. Bits over std c++.header, and we will perform this sorting operation on a string. So I will include the string.header class too. Let me define the range to 55. Now let's write our count sort method. Void sort will accept a character type of array. our integer count. It will be the range plus 1 and our I. Now I think this video is already got very lengthy. We will continue this code from our next video. Till then, take care and stay tuned for the second part of this video.